let me introduce you to Lionel, who's going to tell us more about the Coala framework. Thank you.
So, hello everyone. My name is Lionel. I work as a DevOps engineer at eVoyageur SNCF. eVoyageur SNCF is a digital factory which addresses the SNCF group digital challenges. We are almost 1,500 of employees working in 3 sites, Lille, Nantes, and Lille. I work in Lille. We address 2 main challenges: digital distribution through we SNCF and Rail Europe internationally, and travel information via the mobile app, l'assistant SNCF. We are delivering to them IT services. Today, we are going to talk about static code analysis. We will start first by do some overview, a quick definition of static code analysis. So we will follow up with the Coala framework and Coala beers, how it's used to do static code analysis in Python. And we will see what are coming next into the framework to ease the use of Python to do static code analysis. And we will finish with the Q&A, if you have questions, of course. Static code analysis. We can define it as a method to extract facts, detect and also fix defects in source code without executing it. They are mainly used to do code quality, code reviews, also compliance, when you have to do compliance tests for security, or you just want to ensure that your code style into the team are well respected. And of course, to detect flaws and try to fix them before running it. The Coala framework. We have a lot of tools today to do static code analysis. As you see, there is a bunch of tools. And the more you have tools, the more you have a way to configure those tools. And it's pretty hard. So let's categorize those tools into analyzers, as you see up there. And you have also the way we use those tools via editors, tools and services, and also the way we consume the result produced by those tools, like exporting your result into JSON or an HTML report. As you see, it's pretty complicated to deal with all those tools and the way we use them. So how can we know? What if we can have one only tools to manage all this mess? That's why Coala has been built. Coala is not pretty much, it's just an API which is language agnostic. That means you use Coala in Python, but you can analyze code from any languages. It supports more than 60 languages for now, programming languages. Let's have a closer look. That's the typical constitution of a static analysis tool. We start by using the code as data, and you have some model extraction to just get data from the code. You then produce an intermediate representation. We can be you have AST. You also got data structures. You could also have call graphs and also control flow graphs. If we zoom out into the main goal of Coala, as I said, you have data structures. For analysis, we have rules that also call routines. In Coala, they call it bears. It's the way you implement your algorithm to do static code analysis. And after that, the produced result, it could be in two forms, outputs and actions. Output is like detecting the way you detect flows and errors. You could have also as an output a fixed recommendation, how we can fix our code, and you get as a result also compliance reports for flows and code styles, as I said before. You also have actions. There is a lot of actions there. Action could be apply a patch or actually fixing the flaws or the defects. Let's see how to quick setup. You could use pip to install Coala bears. You install everything you need to start working with Coala. Or you could also use Docker, which I think is the recommended way because it doesn't have to deal with pip packages. You just use the container which is packaged up with all the things you need. You have another way, which is online. You have a beta web page online where you can just put the repository of your code and start working on it. Let's see how to use Coala. Let's see some code. First, you clone the project, and as you see, you have a bears directory and the src directory. In this project, we have mainly two languages. We have C and Python. And the way you approach the use of Coala is by saying, okay, I have a project with two languages. Let's list the available bears, the available rules that I could use to analyze my code. So you run this, and you see a bunch of bears available. For the next slides, I will just aliases Coala to make the slide more short. So you just run Coala, and it means running Coala behind Docker. So I want to analyze my code written in Python. I will list the bears available for Python. Here I choose the Pep8 bear, for example. I don't know much about it, so I get some documentation how to use it. And I see also we have optional settings, how to set the configuration for the bears, and what the bears can do. The bears can detect formatting and can fix formatting. So you run your bears, you run Coala, and specifying the bears Pep8 on your Python files. First, you will get a GIF output. It says how your code is not compliant to the Pep8 rules. And after that, you have action, as I said before. You can either do nothing or open the files, apply the patch, which means make the code compliant, and also ignore the comment. And you have, you can also apply patches at the command line to do the apply patch action directly. You also have another option to specify which action you need to do. As you have noticed, you also, the tools recommended you or suggest you to use --save to save your configuration. That's mainly brought us to the configuration file. As I said, you have a lot of tools and you have a lot of configuration files to tell how the tools should analyze your code. In Coala, you also have one file to deal with all bills. When you run with --save, it produces a file called a Coala file. It looks like this. You have sections, it's an init file, you have sections, and you have at least two mandatory settings, which is specifying the bills, the rules you need to apply on the code, and the file you need to be applying on. You can also enter your settings at the command line, as you see in the int. In the configuration file, you have a way to organize your bills. This to avoid repeating yourself in the configuration. So you have inheritance. You just have to prefix the section with a base settings, base section name. And as you see, section 1 and 2 extend from the configuration set at the base section. You also have append operators, which you can, like this, append files from section to section. As you see, at the base, I'm only analyzing Python files, and at section 1, I want to analyze not only Python files, but also C files. That's an example. I have all this specify org section, and at the example section, I want to check also if the space are consistent in my code. Okay, let's see how BIOS works and what are BIOS really and how to create your own BIOS. As I said, BIOS are only rules, but BIOS are the base construct when you need to write a rule. You have to implement the run function. And the run function is the one which is executed to run your algorithm. From the BIOS, you have two classes, local BIOS and global BIOS. Actually, your code should extend from those two ones. And you also can have user input at the args, which is provided by the framework. Local BIOS runs on every file of your project. And the run function provide the file name and the file content for you to run your algorithm. Also user input and settings. And global BIOS are to run analysis on the whole project. As you see in the run function, you don't have the file, but you can do some internal things to do whatever you want with your files. Let's see an example. I have a hello world beer, and now I just print some logging things. So I extend from the local beer. That means I want to run it on every file and just output a user input which is provided by the user. And at the end, the rule is that you have to yield the result. Why? Because when you mixed beers, you could get the result from any beers in your beers. If you have dependent beers, you can get the result, provide the result getting from the inner beers you have used in your beer. I run it, and that's the output. It suggests me to enter my user input, and I put my name, and it suggests me, as you saw before, action to do on this. So beers. In beers, to write a beers, you have three main categories. You have native beers, linters, to do linting, and you have external beers. What are native beers? Native beers are the beers that extend for local beers and global beers. Simply like this. If you want an example, that's a native beer. As you saw, the Hello World beers was the native beer. Then I just implement the run function and yield some results. And the global beers aside also do the analysis on the world project. Linter beers use your own tools and wrap your tools. Just imagine you have a linter like GSLint, and you want to use Coala to wrap it. That's why you use a linter beer. You specify the executable, and you have to say if this beer is a global or not. If it's global, it means your tools analyze the whole project. And if not, it means just your tools analyze the file, each file over file. The particularity there is that the linter beer has to implement the create arguments. That's how you pass arguments to your executable. We'll see an example. And you have also the way to provide a configuration. If you have a tool that a highly configurable file, you can just do everything in the generate config, produce the JSON you need to execute your tools, and it will be injected in the create argument after that. Let's see an example to see how it works. I have PyLint that I need to wrap. So create the create argument function. That's where I return a list, a tuple. The tuple contains every options PyLint need to analyze my code. That's simply how it works. And from the output specified there, you specify how you want to analyze it and interpret the result. External beers is wrapping also your beers, your tool, but written in any language. Coala will provide you some data in JSON, and you have, as a rule, you have to produce this result which will be analyzed or used by Coala. As an example, I create a beer I wrap my tool with using Node. I create my script in Node.js. And after that, with my add result, I produce the JSON wanted for my tools to be considered as a beer. Like this. I should use console log to show, to output it as a JSON. Going further, the new thing that will come up is they are creating a way to provide to us the AST of any language, a new API using the aspect-oriented programming with aspect and taste, and a new package manager to just specify your requirements in your beers, and it will go fetch your NPM package or your pip package inside your beers to be sure that when your beers run, you have everything you need to analyze your code. Thank you.
Yeah, we still have time for a few questions. This gentleman here. Oh, yes.
Hi. With Coala, are you able to do some kind of semantic static analysis to deduce some properties of your program or so on?
The question was, can I... the question was, can I do some semantic analysis? I will answer that yes. You have just a run function, so you can do whatever you want.
In the examples, I didn't see the access to the intermediate representation.
Oh, the intermediate representation in that case was just a Python data structure. The Coala, for the local base, Coala gives you the file content and the file name. And you can work with this. And if you have the file content, you can do whatever you want with your tools that do semantic analysis on this. That's how it works. And they saw that was a little complicated, and you cannot do much with these simple constructs. That's why I said they are working on bringing some real tools to give you more abilities. Yes? Oh, wait.
Any additional question?
You mentioned it's a language agnostic. Can you use it for Python 2.7 as well?
Can you speak aloud? I don't. Oh, wait. Yes.
Can you use it for Python 2.7 as well?
Python 2. I think I said that it was available for Python 3. I think 3. Yes.
It supports 60 languages.
Oh.
It supports 60 languages.
Yes. Oh, it's hard. Right. Oh man. Yes.
It supports 60 languages. So you could analyze a C program in Python with the complete AST from C?
Yes.
It depends on the compiler options. How does that work?
Yes. The question was, Coala supports 60 languages, and you can use Python to analyze C code. And how it works.
Yes, that's my question. Because it depends on the compiler options, flags.
Yes, you can use the linter beer, and provide your compiler compiler option via the beers. You have to see it as a wrapper.
Okay.
That's why I think is very powerful, because you can have just one tool and do whatever you want with what exists, what is out there to do analysis. Any question? Okay, thank you.
Thank you very much.